Hello and welcome to another episode of Better Together at Math with Shinrai Sensei. And today we're going to be covering translating sentences into math problems because you're very rarely in the real world going to encounter a situation where somebody just straight up rattles off an expression or equation to you, and you're going to have to kind of figure out what they're saying and how it translates into a math problem that you can actually solve. Like your boss at if you're working an office job, let's say your boss isn't gonna sit there and tell you, all right, you need to subtract 20% from this in order to figure out how much we need to pay in taxes. He's going to tell you that our taxes are based off of our income and it's supposed to be 20%, and can you figure out how much taxes we need to pay based on that? That's, like I said, it's about using real world conversations and figuring out how math comes out, how to write math based on conversations, right? And so we have a 3-step process to translate a sentence to a math problem. Okay, first is you identify the unknown. Okay, second, represent the first unknown with a variable. So most people's go-to variables x, but you can use whatever variable is more appropriate to the equation or expression. And in fact, you'll almost always have equations. It's really difficult to make a sentence that's an expression, so it'll almost always be an equation. Any other unknowns, though, you'll represent with variable expressions, right? So how that variable relates to something else, which will be demonstrated in the third example, but I'll explain that when we get to it, right? And in step 3, use what you found in step 2 and information from the problem to write an equation. Okay, so first example is twice the sum of a number and 4 is 10. Okay, twice the sum of a number and 4 is 10. Now, if you want to make it easier for you to write, you can always start with what the value you're supposed to be getting is. So in this case, 10. You can write the 10 over here and then equals 2 times the sum of a number. So a number is x, right? And 4. So in parentheses here, we have x plus 4 because it's the sum of a number and 4 being multiplied twice. So the addition has to happen before the multiplication. So you have to put the parentheses around this. Otherwise, it just turns into 2 times x plus 4, which means that the addition happens after the multiplication, right? Basic order of operations, but it's always good to refresh on that. So you have to put this in the parentheses because x plus 4 has to happen before the multiplication of 2, right? And we could solve these if we wanted to, but mainly what we're focusing on right now is translating these into a solvable equation, or even an equation that you can't solve necessarily. Translating this into the equation is the important part today. So we're not going to solve these problems. We're just going to translate the sentence into an equation, and then we're going to let the equation just be there. Feel free to take a screenshot of the board at any point in time. I want you guys to have all the resources you can. And let's continue. So twice the sum of a number and 4 is 10. So 2 times parentheses of x plus 4, close parentheses, equals 10. That's how you would write that out. So 2 times the sum of a number and 4, 2 times the parentheses x plus 4, close parentheses, is 10. Is always equal to. Okay? Now, example number 2. The area of a rectangle is 102 centimeters squared, and the length is 6 centimeters. Find the width. So, first you have to know what the formula for area is, which in the case of a rectangle or any other parallelogram is length times width, right? Then you just have to substitute the values in accordingly. So area, 102 centimeters squared, is equal to length, 6 centimeters, times width, which is unknown, so we put W. Okay? That one's easy because, like I said, there's already a formula. All you have to do is plug and play. And once again, we could solve for W if we wanted to. Pardon me. We could solve for the width if we wanted to, now that we have it written out. And I'm sure that in some, lower level elementary math, when you're learning area and stuff like that, they do give you some written word problems a lot. At least when I was in school, they did. I don't know how prevalent that still is. But they'll still give you written word problems like this and ask you to solve. And you can solve this relatively easily, even if you don't fully translate it into the formula. You can still solve it relatively easily. But just so you can get the visual of the math problem, just translate it into that formula. So this one's easy, like I said, because it has a formula. All you got to do is plug the plug the data in, so the area and the length we know, and then the width we don't, and then the width just represent with a W. Okay? Now, number 3 here, this is where it starts to get a little trickier, and so that's why I really wanted to use this example for you guys. Okay? So Alan has $6 more than Bill. Together, they have $30. Find how much money Bill has, right? So in this case, we're going to use B for the money Bill has. And you'll see that if you look at this equation that I've written. So first, I started out with the $30 being on this side of the equal sign. It doesn't matter which side of the equal sign things are on, as far as for the purposes of what order you write things out in, as long as they're on the appropriate side of the equal sign and they aren't written on the wrong side of the equal sign. It doesn't matter if you have this side with everything going on and this side is a solution, or this side is the solution and this side is the math, right? So long as everything is on the correct side of the equal sign, that's all that matters, okay? So $30 we know is equal to, in this case, Bill has less money, so it's easier to add value and less. The problem looks less complicated when you have an addition sign. Okay, from a psychological perspective, an addition sign looks less complicated and, well, less negative than a subtraction sign would be here. So instead of using Alan as the base here, we're going to use Bill, because Bill plus $6 is how much Alan has, and Bill's money needs to be added to Bill plus 6. All right? Now, once again, you can solve this if you want to, but that's not our goal. Our goal is to translate this into a sentence. An alternative writing using subtraction would be Alan plus a parenthesis of Alan minus 6, because he has $6 more. And so this would give you Bill's amount, Alan minus 6, plus Alan. Okay? So this is correct as well. So if you want to base it off of Alan, and that's why I chose A and B, just like I chose W for the width here. As far as this one goes, there was no reason why I went with X. It's just what most people will typically go for when they start substituting values or variables in for an unknown value, right? But in this case, I would prefer to use A for Alan if I'm going to base the values off of Alan's money, like the sentence seems to. Or I can go with Bill's money, which is here, and make all of it addition, which means, by the way, this is the simpler problem to solve. Because in order to solve this one, I have to change this to A plus negative 6 in order to have A plus A, which is 2A plus negative 6 is equal to 30, right? So this is easier to solve because it's 2B plus 6 is equal to 30, right? But this is still acceptable. It's just a little bit extra steps to solve it, right? But like I said, we're not focused on solving these today. We're just focused on translating. So that will conclude the lesson for today. That was translating sentences into math problems. If you guys want, if this is helpful, please take a screenshot of the page, take a picture, whatever you got to do. I really want you guys to have these resources. So let me know if you guys want me to. I can always update this on my like community page or something like that, somewhere that you guys can easily access it. But I hope you guys got good, useful information out of this, and I look forward to seeing you guys in the next one. Peace.